Welcome to the 18th episode of Byte-Sized JavaScript. In this episode, we'll be talking about different ways to control the flow of information in our applications. And before we begin that, let me introduce you with the JS102 repository. The JS102 repository contains bite-sized examples about fundamental JavaScript concepts, and it aims to teach the building blocks of JavaScript without relying on external libraries and frameworks, so that you can reveal the magic by learning more about the important parts of the language without getting distracted. So every once in a while in the screencast we'll be working on this repository in order to cover important theoretical concepts and the building blocks of the language. And this is open source, as you know, so feel free to clone the repository and play along with examples yourself. And I truly appreciate any comments and suggestions as well. So if you feel like there are missing parts that can be expressed better, or there are topics that needs to be covered but that has not been covered on the repository yet, just let me know about it and I'll make sure that the topics are updated accordingly. And without further ado, let's open this repository in our IDE. And also I'll install Node version 7.2.0 to this workspace because it has better JavaScript support for the more modern features of the language. For fat arrows or the destructuring syntax or template strings or the class notation and stuff like that. And as you see, we have folders that are logically split into different topics, and to test any module that you see in these folders, you just run any file inside the folders using Node, and you'll get a sample output as you see here. And also inside the source code, there are useful documentation commands and footnotes to grab your attention to important highlights and gotchas of the subject matter. And in this episode, we'll be talking about promises and other flow structures, as I said. And before you begin, I strongly suggest you pause this video and go read the Promises A+ specification from this link that you see here. So I hope you read the promises specification and you have a kind of a vague understanding of how promises function. So here is the specs page for the interested. And as you see, it's just a single web page that outlines how promises behave. And especially this resolution procedure is really important, and we'll be covering how promises resolve in depth with further examples in this episode. To broadly outline how promises work, first of all, you have to create a new promise with the new operator. And a promise is nothing but a boxed computation that executes in the future. And in that regard, a promise behaves much similar to the monad construct in functional programming. And the promise can have three different states. Either it's pending, or it is fulfilled, or it is rejected. And when the promise resolves, the unfulfilled handler is called with the resolution value. And when the promise is rejected, or when an exception is thrown while doing some computation inside the promise's body, the unrejected handler is called with the rejection reason. And also the promise has a then method which also returns a promise, which helps you to chain promises, and we'll see examples of that as well. Additionally, the concept of returning data inside a promise is a little different, because when you return inside the promise's body, which is the promise's callback function, it does nothing. So in order to pass the data, you either have to resolve or reject inside the promise. So forget about the return keyword, because resolve is the new return. And forget about the throw statement, because reject is the new throw statement in promised land, basically. Any exception when computing the promise will result in the rejection of the promise, and if you resolve the promise with another promise, the promise will accept the fate of this inner promise. So when the second promise, which is the inner promise, is fulfilled, the outer promise will also be fulfilled with the fate of the inner promise. And when the inner promise gets rejected, the outer promise will be rejected by the rejection reason of the inner promise. A promise has a then method that takes an unfulfilled and unrejected callback, and the unfulfilled callback is called with the resolution value once the promise is resolved, and the unrejected callback is called with the rejection reason or the exception that has been thrown when the promise gets rejected. And this one is important. One of the most important features of a promise is once it is fulfilled, it is immutable, so its state never changes. So once you fulfill a promise, it will retain its value and its state forever. And because promises are boxed computations, they are also thunks in a sense, and they are also monads, and they are also functors by definition. In addition to all this, if you are curious enough and if you want to implement a promise by yourself to learn how it works, this library here is a minimal implementation that conforms with the Promises A+ specification. And if you look at the source code, you'll see that it's really well written and it's easy to follow. So feel free to fork it and experiment with it. I guess that's enough theory, so let's begin with a simple promise example, shall we? To recap, here's how we create a new promise. So let's create our first promise that resolves with the number 42 after 1 second. And also, if you remember, promises has a then method which returns another promise. So we can use this then method to do something with the resolution value once the promise gets resolved. So in our case, promise 2 will be fulfilled with 1/2 of the resolution value of the promise 1 once promise 1 resolves with 42 after 1 second from now. And since promise 2 also has a then method that returns another promise, we can chain it as follows. Now let's do something different and return a promise instead of a primitive value or a simple object from this then method. And in this then, we fulfilled the promise 2 with a primitive. And in this then, and this is important, we'll be fulfilling promise 3 with the eventual fate of promise 4. So promise 3 waits for promise 4 to get fulfilled and then behaves exactly like promise 4. To recap, you can either return a non-promise value from the unfulfilled or unrejected handlers, or you can return a promise. And if what you return is a promise, then the outer promise which this then method returns will assume the fate of the inner promise. And if it is a non-promise value, then the outer promise will be resolved with that value that you return. Also, promises and promise-like objects are sometimes called thanables because you can chain them by calling then methods back to back. So let's make this innermost promise resolve after 3 seconds. So when you run this example, we'll wait for 1 second, then promise 1 will resolve with the value 42. Then we'll return half of that value inside this unfulfilled handler, which will make promise 2 resolve with 21, which in turn will trigger the unfulfilled handler inside the then method of promise 2. There we'll create a promise 4 only to resolve after 3 seconds, and when promise 4 resolves with twice 21, which is 42, promise 3 accepts the fate of promise 4, and it also resolves with number 42, which triggers the then method of the promise 3, and it results in us logging 42 to the console. One cool thing is, since then always returns a promise, and promise always has a then method, we can simplify this code by removing bits and pieces and chaining things together. And when we run this code, the behavior will be exactly the same as the former one. Next up, we'll look at another important feature of promises, which is promises are always asynchronous. So if we look into this code piece where we log before and after we construct a promise, first these two log lines will be executed, and the promise body will be evaluated on a different stack frame on the next process tick. So when we run it, we get before, after, and 42 in that order. And if you are immediately resolving a value inside a promise as you see here, you can also use this promise.resolve shorthand notation. So how was life before promises? Well, at least in Node.js, there was the concept of nodebacks or node callbacks, which has the error state as the first parameter and the result of the computation as the second parameter. We'll see how that looks momentarily, but before that, let's create a fake network library that kind of mocks an AJAX request and response to a server. For this, we'll take a URL to make a request to and a callback function as arguments. And after some time, we'll flip a coin and call the callback with an error state roughly 80% of the time and call the callback with a success state roughly around 20% of the time. So Node.js core modules extensively use this nodeback approach to manage their flow control. The protocol is the first argument will be always an error, and if there is an error, the second argument will be null. And similarly, if everything is successful, the first argument will be null because there is no error, and the second argument will be the result of the asynchronous computation. Indeed, this methodology that Node.js uses is way older than Node.js itself, and it is known as continuation passing style. You can visit this link that you see here to get some further insight about it. So does it sound similar to promises? Of course it does. Because in promises you resolve or reject instead of directly returning something, and in CPS instead of directly returning something, you call a callback. These two solutions are handling the same problem with slightly different but compatible approaches. That's why there are also promisification libraries that can take a Node.js nodeback and return a higher order function that returns a promise when called. For instance, Bluebird's Promisify function is a good example to that. After this mini discussion, let's go back to our code, shall we? We will use the fetch alias for our fake AJAX call since we are simulating nothing but a network fetch operation. So we'll fetch a URL, and if we get an error, we'll log the error and return, and if we get a response, we'll again log the response and return. And here's how it looks like when we run the code. So as you see, the result of this fetch operation is random. Sometimes it fails and sometimes it succeeds. And as an end user, we may want to retry this request several times in order to make sure that you get a successful response. So let's assume that you want to retry your request until you get a success response. So how can we do it? For one, once there's an error, we want to fetch until we are successful. And if this fetch until success method can call this fetch operation once again, we should be all set, I guess. So let's try this algorithm by calling fetch until success and see what happens on the console. And as you see, we get a bunch of failed responses, and then eventually we get a success response, and then our program exits. I also want to inject some timeout here so that it feels more like an actual network request. Now when we run it, we get a slower step-by-step response, which is more realistic. Now let's try to promisify this structure. For this, I'll rename our fake AJAX call as fetch CPS since it is a continuation passing style based API, and then we'll create a fetch function that returns a new promise by just copying this chunk of code and pasting it here inside this promise body. And since there is no concept of returning an error code or throwing an exception in the promised land, we'll reject when there is an error and we'll resolve when the request is successful. Also, we'll pass this URL as an input argument to this function so that we can reuse the same code for different endpoints as well. So fetch until success will be just calling fetch and waiting for its then or catch handlers to fire. And if the then handler fires, then we are all good since we have successfully retrieved the result. So we'll just return the result in the handler as you see here. And if it fails though, we'll return fetch until success, and since fetch until success returns a new promise, this will essentially mean that our initial promise will wait for the resolution value of this inner promise before it gets resolved. We then can chain to that chain of promises by calling this then function and log the successful outcome inside the callback. This is a nifty way to recursively call a promise to retry an AJAX function over and over again until it gets a successful response. And that's a great point to stop as well. In summary, in this episode we learned about what continuation passing style is, and also we studied the Promise A+ contract with some examples. If you are seeing this kind of a thing for the first time, it might take a while to wrap your head around, so I'd go over the examples that we covered here and also check the JS102 repository to get comfortable with the overall concept of promises. Why? Because in the next episode we'll continue from here and we'll be examining more complex promise usage patterns and also look into other flavors of flow control such as iterators and generators, async await, and of course observables. And until then, may the source be with you.